We'll start with elasticity and plasticity. So elasticity means what? It is a property of the material which allows, it is a property of the material which regains, by which it regains its original shape after the removal of the external force. Property of the material, it is the property of the material, by which it regains its original shape and size after the removal of external force. Example for this is what? Example for this is rubber band. Okay, so rubber band is a best example of elasticity. Next is what? Plasticity. What is the meaning of plasticity? It is a property of the material. It is a property of the material by which it remains in the deformed state. It remains in the deformed state after the removal of the external force. So example for this is, you can take plasticine is a best example. Plasticine or plastic bottle, these are the good examples. Of plasticity. Next one we have stress and strain. What is stress? The stress is the restoring force per unit area. Stress and strain. Okay, 1 second. So stress and strain is okay. So just take the screenshot, then we can go to the next one.
Yes, sir, done.
Next one. So here we have stress. Stress is what? Stress is, we write like this, sigma. Stress is sigma. That is restoring force. The restoring force acting per unit area. Restoring force acting per unit area. Okay. Restoring force acting per unit area is said to be stress. Now, stress, the formula of stress is force per unit area. Formula of stress is force per unit area. Now, we can also write sigma equal to what? F by A, force per unit area. And units of stress is Newton per meter square, or we write Pascal also. Next is strain. Strain is epsilon. We denote it by epsilon. Strain is the ratio of change in the length by original length. Okay, so the ratio of change in original length, the ratio of change in original length to the ratio of change in the original length to the or we can write change in the length, the ratio of change in the length to the original length, to the change in the length to original length. Okay, so that is said to be strain. So we can write here a strain equal to change in length by divided by original length. change in length by original length. So we have E is equal to delta L by L. So it has no units for strain. Okay. Yeah, I'm going to the stress. First definition of stress and then strain. Then I will go to types of stress and types of strain. Okay. I'll go to types of stress and types of strain. Types of stress and types of strain. Okay. Now take a screenshot. We'll go quickly to the types of stress and types of strain. Now, what are the types of stress? What are the types of stress? So here, types of stress. Types of stress. There are three types of stress. What are they? Longitudinal stress. Longitudinal stress. Second one is normal stress. Longitudinal stress, normal stress. Third one is shearing stress. Shearing stress or tensile stress. Shearing stress or tensile stress. In this, again, there is a classification A and B. One is tangential stress. Sorry, here it is tangential stress, and this is tensile, and the second one is two are there in that tensile. Yeah, tensile stress and compressive stress. Tensile stresses and second one is compressive stress. There are two. Okay, one is longitudinal stress, tensile and compressive in that. Second is normal stress. Third one is tangential stress or shearing stress. Okay, so first we will go with the, if it is along the length, if the first one, see in longitudinal stress, what he says, if the stress is along the longitudinal stress, he says that if it is along the, if the stress is along the length, then that is said to be longitudinal stress. In that we have tensile. If I speak about tensile, it is we write same formula for F is equal to, sigma equal to F by A, force per unit area, which is along the length. Okay, if the stress, here stress is along the length, stress is along the length, then that is said to be longitudinal stress. So here we have tensile stress. Tensile stress means if the stress is outward, then that is said to be tensile stress. Next one is compressive stress. Example for tensile stress is rubber band. Okay, rubber band is a best example for tensile stress. The next one comes compressive stress. Compressive stress means, like, best example is sponge. Okay, that means inward force. Here this is outward and this is inward. The difference, this is tensile is outward and compressive is inward. Okay, so going to the next one. So clear, just take a screenshot, then we'll go to the next one. Take a screenshot, we'll go to the next. So in the next one, we have that is volume, that is normal stress and shearing stress. Normal stress means, now, so next one is, we have normal stress and volume stress. So sorry, shearing stress. So second one, we have normal stress. So what is normal stress? So if the force is acting, means if the deforming force is applied uniformly and normally of the body, or we can say deforming force per unit area normal to the surface. Okay, so deforming force acting normal to the surface. Deforming force acting normal to the surface. Okay, or we can say deforming force acting normal to the surface is pressure and restoring force. restoring force developed in the body, restoring force developed inside the body, per unit area, normal to the surface, normal to the surface is known as stress. Okay, is known as stress. Okay, now the next one is what? So example for this normal stress is, suppose if you are taking a body like this and if you are applying the force in this way, then what happens? Actual volume will go down. Okay, see, the total volume is going down. So then that is said to be normal stress. Next is tangential stress, which is acting tangentially to the surface of the body. Okay, so next is tangential force, which is acting tangential to the surface of the body. So I'll not write the definitions now. Now, the third one is tangential stress. So tangential stress, it says that if the force is deforming force acts tangential or parallel to the surface of the body without change in the volume. Okay, there is no change in the volume. Such type of stress is known as shearing stress, or we can also say shearing stress or tangential stress. So now example, suppose there is a book now, so I am applying the force in this way, that is on the surface, then there is a restoring force, so because of which the book got deformed in this way, but actual volume remains same. So such type of yes ma'am, such type of stress is known as hydraulic stress. The shearing stress. Okay, next is strain. Next comes strain. Is it clear, all the three types of stress? So quickly, see, stress is restoring force acting when you apply some force, the body is reflecting to that one, so that is said to be restoring force. Restoring force acting to the body, that is to the area, to the surface area, is known as stress. We have three types of stress. That is the first one is what is that? Longitudinal stress, normal stress. Then third is tangential stress. So longitudinal stress again classified into two. That is, one is along the length, that is both are along the length, that is tensile and compressive. So the next is normal. Normal stress means if the force is acting normally, like a football is immersed in the, or a small balloon is immersed in the water, then what happens? The volume will get reduced. So that is said to be normal stress. And the third one is tangential stress, means only along the tangent of the body we are applying the force, then that is said to be tangential stress. Okay, next one is strain. So there are three types of strain. What are they? The first one is strain is defined as change in dimension per unit dimension. There are three types of strain. So there are three types of strain. Number one, strain is of three types. So first one is longitudinal strain. Second one is volume strain. Third one is shearing strain. Volume strain, linear strain, volume strain, and shearing strain. So linear strain is known as, linear strain is equal to what? Or we can say linear strain or longitudinal. Linear strain. So linear strain equal to what? It is change in length by original length. Change in length divided by original length. Change in length by original length, that is equal to what? Delta L by L. Okay. The next one is volume strain. Volume strain is change in volume by original volume. That is equal to change in volume divided by original volume. Change in volume by original volume. So that is equal to delta V by V. Third one is shearing strain. Shearing strain is what? It is given by theta is equal to delta X by Y. I am writing. What is delta X and what is Y? See here, this was the actual book, shape of the book. We applied the force here. This is the applied force and this is the restoring force. Because of which the book which was in this way, it got deformed. The bottom surface is as it is, only the top surface got deformed. So it was actually in this way, the dotted line. So it is making an angle theta. And how much displacement took place, that is x, and this is the y. So tan delta theta is equal to what? Theta is equal to delta x by, this value is delta x. Theta is equal to delta x by y. Now, we'll quickly move to the next concept. So we have three types of stress. We have three types of strain. Now after that we have Hooke's law. According to Hooke's law, he says that, okay, Robert Hooke, he gave his statement. Hooke's law says that there is under elastic limit, stress is directly proportional to, under elastic limit, stress is directly proportional to strain. Stress is proportional to strain. Stress is proportional to strain. Okay, and the second one is what? One more statement he has given, or we can also say under elastic limit. Okay, so we can also write under elastic limit, force is proportional to extension. Force is proportional to extension. Okay, under elastic limit, force is proportional to extension. We can write in this way also. Next one. After that, we have stress strain curve for a metallic wire. We'll do that. Then quickly we'll move to the water elastomers. This topic is important. Stress strain curve of a metallic wire is important. So from there we can find the three modulus of elasticity. Okay, what are the three different modulus? That is Young's modulus, bulk modulus, and rigidity modulus. These three modulus we have to discuss. Okay, now there are two statements for Hooke's law. Under elastic limit, stress is directly proportional to strain, or force is proportional to extension. Now, force is proportional to extension. We will do this. Next comes the next one. Here we have Young's modulus. There are in modulus, so stress is directly proportional to strain. Stress is proportional to strain. So to remove this proportionality, we are multiplying with some constant. Okay, so that we are writing like there is a constant. Stress by strain is constant. Stress by strain equal to constant. Okay, that constant can be a Young's modulus or bulk modulus or rigidity modulus. This is E is said to be here constant capital E. So E is said to be modulus of elasticity. E is said to be modulus of elasticity. E is said to be modulus of elasticity. So the first one we'll discuss. There are three types of modulus. Okay, types of modulus. What are the types of modulus? Types of modulus. Well, the first one is Young's modulus. Young's modulus. The second one is bulk modulus. Young's modulus, bulk modulus. Third one is rigidity modulus. Young's modulus, bulk modulus, and the third one comes, that is modulus of rigidity or shearing modulus, shear modulus. Rigidity modulus or shear modulus or shear modulus. So what are they? We'll write quickly here. So Young's modulus y is equal to longitudinal stress by longitudinal strain. Okay, that is